In this problem, hot water enters the tube side of a shell and tube heat exchanger at a temperature of 250 degrees Celsius, a pressure of 1000 psig, and a mass flow rate of 100 kilograms per hour. Inside the heat exchanger, it transfers heat to a cold water stream flowing through the shell side. The cold water enters at 25 degrees Celsius and 130 psig. During heat exchange, the temperature of the hot water decreases from 250 degrees Celsius to 190 degrees Celsius. The pressure remains constant, assuming 0 kilopascal pressure drop on the tube side. The mass flow rate also remains the same. At the same time, the temperature of the cold water increases from 25 degrees Celsius to 150 degrees Celsius. Its pressure also remains constant, assuming no pressure drop. We need to simulate this problem in Aspen Hysys to find out the flow rate of the cold water. Open Aspen Hysys software. Click on New button. Click Add to open the component list. Add the pure components by typing their names in the search bar and pressing Enter. Enter water as component. Select the fluid package option and click Add to include a property package. From the list, scroll down and select Pung-Robinson. Finally, click Simulation to add the compressor and material streams. Add a material stream by dragging the blue arrow from the object palette. Double-click the stream to enter properties of hot fluid and name it Tube In. Set the temperature to 250 degrees Celsius, the pressure to 1000 psig, and mass flow rate to 100 kilograms per hour. Next, open the Composition tab and enter the mole fraction of water, that is, 1 in this case. After defining the composition, click OK and close the material stream window. Add another material stream. Double-click the stream to enter the properties of the cold fluid and name it Shell In. Set the temperature to 25 degrees Celsius, the pressure to 130 psig, and the mass flow rate is unknown. Next, open the Composition tab and enter the mole fraction of water, that is, 1 in this case. After defining the composition, click OK and close the material stream window. Colors also show the status of streams. Light blue icon indicates the stream cannot be flashed until some addition information is supplied. Dark blue icon indicates the stream has been flashed and is entirely known. Drag the heat exchanger icon onto the flowsheet. The heat exchanger model performs energy and material balance calculations on both tube and shell sides of the unit. It can calculate important process variables such as temperatures, pressures, and heat flow between the hot and cold streams. It also accounts for heat loss or heat leak to the surroundings. In addition, the heat exchanger model can determine material flow rates and the overall heat transfer coefficient, known as UA. Double-click the heat exchanger icon to open its window and rename it Heat Exchanger. In the tube side inlet field, select Tube In. In the tube side outlet field, enter Tube Out to create a new material stream. Similarly, in the shell side inlet field, select Shell In. In the shell side outlet field, enter Shell Out to create a new material stream. Switch to the Parameters tab. Select Simple Endpoint as the heat exchanger model. This model is a basic heat exchanger model used when outlet conditions are known or easily estimated. It performs energy balance calculations without detailed geometry specifications. Set the tube side and shell side pressure drops to 0 kilopascals. Keep all other parameters at their default values. The yellow status bar shows that the heat exchanger is underdefined. To define it completely, go to the Worksheet tab. Enter the outlet temperature of hot fluid that is 190 degrees Celsius. Also, add the cold fluid outlet temperature that is 150 degrees Celsius. Now, the status bar turned green, confirming that the heat exchanger is fully defined and results are available. The mass flow rate of cold fluid is 55.21 kilograms per hour.